Welcome all of you. This is another video of Animaths. We are continuing with physics here. Okay, as we know, we have already done two videos on physics. We have taken up light for the very first video. So we are continuing with light here. Today I am going to start with the diagrams of light, that is the cases of light. That is where if we keep the object, where we should keep the object, and correspondingly where do we get the image. Like if we keep the object at center of curvature, where do we get the image? If we keep the object at the focus, where do we get the image, and what are the characteristics of the image? So we are going to take up this in this particular video. Note one thing while I am doing these diagrams, when I am drawing these diagrams will be following the rules of reflection exactly. The rules of reflection of a concave or a convex mirror, that is of spherical mirrors. I have finished the rules of explaining the rules of reflection of a concave or a convex mirror in the past, in the last video. Okay, so you'll find the link in the description box, so you can refer there if you're finding it difficult to understand these particular diagrams. Okay, so you can find it difficult, you might think that it is, if you are not understanding these diagrams, please go back to those diagrams, the past video, and that is light part 2. In light part 2 you are going to get them, and take a look at the diagrams and listen to the explanation. You'll be able to follow today's video then. Okay, so let us see. Now let us start with concave mirrors. Okay, we'll start with concave mirrors. Case 1 for concave mirrors. Concave mirrors. Okay, this is the first case for concave mirrors. In concave mirrors, this is case 1. Object at infinity. Object is at infinity. Then how do we get the image? Now here is the concave mirror. Okay, so I am silvering one side. Okay, this is my principal axis. So here is the pole. If I measure, now here when you draw them, you have to be very careful about taking this length. If you have taken in your notebook this as 2 centimeters, see to it that here to C also you take as 2 centimeter. Okay, then you will get your diagrams correct. If this is increased, if this is more than this, or this is more than the FC, then your diagrams will automatically go wrong. Okay, now here the first diagram is object is at infinity. Now if the object is at infinity, then the rays are coming, any ray which comes from infinity are considered parallel to each other. So the rays are coming parallel to the principal axis. In this case we'll have another. Now it is not necessary that every time the rays are parallel to one another they should come parallel to the principal axis also, not necessary at all. Okay, so they are parallel to each other. Rays coming from infinity, we assume that the rays are parallel to each other, that is it. In the next diagram we'll see that rays are not parallel to principal axis. Even then what happens? Now if a ray is coming parallel to the principal axis, it will converge at the focus. Another ray, this also came parallel to the principal axis, this will converge at the focus. Okay, now if you are seeing from here, you get the idea that these two rays are coming to your eye from this point. So you get the idea that the image is formed over here where the two reflected rays meet. Don't forget to put the arrows, absolutely important. So this is the diagram when the object is at infinity and rays are parallel to principal axis. Okay, then now what are the characteristics of this? Characteristics of this image. Firstly, it is diminished. It is a diminished image. Yeah, okay, it's a real image because rays are actually meeting here. Okay, at F, that is at the focus the image is formed. So this is not only diminished, I should say highly diminished. Highly diminished image, real image at F. Okay, and since it is so diminished, we don't talk about it being inverted or not. Okay, so it is highly diminished, so we don't talk about it being inverted or not. It basically reduces to a point image, okay, but any real image is always inverted. Okay, so this was the diagram for object is at infinity and rays are coming parallel to the principal axis. Now let us see the next diagram. Here, this is the concave mirror. Once again, here is our principal axis, this is the pole, the focus and the center of curvature. Now rays are not parallel, so rays not parallel to principal axis. This is the next diagram. Now what we see in this is one of the rays, it just comes and strikes the mirror at any point. It just comes and strikes it at, let's say, just comes and strikes it at any point and gets reflected like this. The other one, it strikes the mirror at the pole, but remember, if it is coming from infinity, the incident rays have to be parallel to one another. Yeah, and then what happens? It strikes at the pole, and according to the laws of reflection, I have told in the rules of reflection that when it strikes at the pole, then it reflects back along the, it just reflects back following the rules of reflection. Okay, now this is the point where the two reflected rays meet. Okay, so if you are looking from here, you will get the idea that the image is formed over here. So it is formed at, okay, since I am not drawing it with measurements, so it has slightly moved from the focus. So here, this is the image is formed at the focus. It is an inverted image. Okay, now I can, if it would be wrong to say image is formed at the focus. Last image was formed at the focus, but this image is not formed exactly at the focus, but it is formed in the focal plane. Now what does that mean? Focal plane is that plane where the image is, where if you place a paper, okay, along the focus, and if you place a paper perpendicular to the principal axis, just like this, okay, so then you will see that the image lies on that paper. That is the meaning of the focal plane. Okay, so if supposing I place a paper like this, it's little difficult to draw, but here, okay, then the image will lie on it. Now it is a real image, of course, because rays have met. Inverted, this time we do write inverted because it is diminished, but then still it has its own little bit of size. Okay, diminished, of course, it has got reduced in size, diminished, real, inverted, diminished, and then the next one is real, inverted, diminished, and it is in the focal plane. Okay, in the focal plane. So if you just say it is in the focus, it would be wrong. So this is the diagram when the rays are coming from infinity, but they are not perpendicular, they are not parallel to the principal axis. Come to case 2. Okay, now case 2 is when the object is beyond the center of curvature. Object beyond C. Okay, back here is my mirror. This is the pole, this is the focus, this is the center of curvature, and now the object is here. Now we must draw the object like this, showing this way the object is erect. One ray will come parallel to the principal axis, okay, and if it is coming parallel according to the rules of reflection, it will go through the focus after reflection. Another ray passes through the focus. Okay, another ray passes through the focus and it goes parallel to the principal axis. As it goes parallel to the principal axis, this is where the reflected rays meet. If you are seeing from here, you get the feeling that the rays are coming from this point. Hence, the image is formed here. Okay, hence the image is formed at that point between F and C. Now you can note clearly that the image is smaller in size and it is formed between F and C. So if I write the characteristics is between image between F and C. Yes, image is between F and C, image is inverted, okay, real image and diminished image. So these are the characteristics of the image formed when the object is beyond C. Okay. So here you will see every time the image is formed, every time the image is formed, okay, it is formed by two reflected rays, the point where two reflected rays meet. And you will note one thing, that whenever I am drawing a diagram, I am only following those 4 laws, the 4 rules that you have learnt in the last video. Okay, lines, rays going parallel to the principal axis, rays going parallel to the principal axis will pass through the focus, ray coming through the focus will go parallel to the principal axis, that's all. Okay, so I am following those. Another thing, now you might think, how, if the rays simply meet, then how is the complete image formed? Now remember, this whole body of object is giving out rays of light from every part of it. It is not that, it's not a candle or anything that only the top tip of it will give. So it is giving reflected rays from the entire body of the object. Okay, and all of them are following the laws of reflection as they should, as it is for a concave mirror. But then we are taking only the outer boundaries, because if you start drawing all of them, okay, if you start drawing all of them, then so all of these are, you know, it's actually like this. So all of them, yeah, so all of them actually are responsible for the formation of this full image, because the entire body, anything is seen by reflected light. So the entire body of the object is giving out reflected light, not only the tip. Please don't take the object as a candle or a lamp which is giving out light from here. Remember, if you can see this marker, if I keep this marker in front of the mirror, even then I'll get its image. No, this is not a luminous object, it's not giving out any light, but still I see its image, because as long as there is a light which is there on in the room, this marker is shining, is being seen by reflected light. So the same reflected light is falling on the mirror and it is making the image. That is the whole story. Okay, so you know, people, they pass out of school and thinking that this tip was glowing and so it formed an image here, but the confusion is, how does it form the full body of the image? Okay, that is a very valid question. Okay, so let us move on to the next. Now this is our third case when the object is at C. Here is the pole, okay, here is the focus, and let me take the center of curvature over here. Okay, so the object is here at the center of curvature. Okay, so here is the focus, here is the center of curvature, and then here goes the ray which is going parallel to the principal axis. Okay, this is the incident ray parallel to the principal axis. Then it passes through the focus. Okay, it then passes through the focus on reflection according to the laws of reflection. Again here, this is the other ray which is coming from the object, and it is going parallel to the it is going through the focus. Now this on reflection will go parallel to the principal axis. Okay, so this on reflection is going parallel to the principal axis here. This is where it goes. Now see, now the object has been formed, the image has been formed at C. Okay, so this diagram is a very symmetrical diagram. This is F, here is C, and the image has been formed exactly at C below the principal axis. So this is the diagram when the object is at C. What are the characteristics? Same size, image is same size. Remember, when I write the characteristics, they are characteristics of the image. Then same size at C, real and inverted image. Okay, so these are the 4 characteristics of the image formed when the object is placed at the center of curvature. Okay, come to the fourth diagram. Okay, the fourth diagram, this is case 4. Object between F and C and F. Okay, so here is the mirror. Okay, then this is the principal axis. This is the principal axis, and this is the principal axis. Let's say here is the focus, then here is this is the focus, and this is the center of curvature. Now we have to place the object between C and F. That is, the object gets placed here. Now between C and F can be anywhere. It can be here, it can be here, or it can be here. It can be anywhere. It's not, between does not mean exactly right at the center. Okay, so here goes one ray parallel from the object. One ray is incident on the mirror, which is parallel to the principal axis, and it goes and passes through the focus. Passes through the focus. Another ray which passes through the focus. Okay, another ray passes through the focus, and now it will go parallel to the principal axis. Okay, so this is going parallel to the principal axis. These two rays have met here. So this is where the image is formed. Okay, this is where the image is formed. It is inverted. Okay, if I say characteristics, they are real, inverted, enlarged. This time you see it has become bigger in size. Real, inverted, enlarged, and beyond C. Okay, so these are the 4 characteristics of the image which has been formed when the object is between C and F. Now here I want to tell you, if I would have taken the object over here, little bit here or here, but between F and C only, the only difference it makes to the image is the image shifts here, 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 somewhere beyond C. Okay, so this position changes, but it is definitely going to remain beyond C as long as you are between, the object is between F and C. Okay, this is the 5th case. Okay, 5th case, when the object is at F. We have done when the object is at infinity. Do not confuse with that. Here is our mirror, and this is our principal axis, and here is the pole, here is the focus, and here is C. Now one ray which is, if the object is at F, so let me draw the object at F. If the object is at F, then one ray which goes parallel to the principal axis, okay, it will pass through the focus. So this is how it passes through the focus. Okay, now another ray which falls on the mirror in such a way that this is directed at the mirror, incident at the mirror in such a way that on taking it back, on retracing it, or you can say on drawing it backwards, it will always pass through the center. So here this ray, the upper one, is being called a ray directed at the center. Now you might think, I am drawing it this way and why is it directed at the center? That is, on tracing it backwards it passes through the center. If it is that kind of a ray, then remember, according to the rule, the ray which is incident at the mirror follows the same path back. Okay, now these two rays are parallel to one another. These two rays are parallel, the reflected rays are parallel to one another. Therefore, characteristics of image formed, they are, of course, it is a real image, highly enlarged image, highly enlarged. Okay, it's a real, highly enlarged image, and it is formed at infinity. It is real image, highly enlarged image. It is formed at infinity, and it is inverted. Okay, so these are the 4 characteristics of the image formed when the object has been placed at the focus. I repeat, one ray coming parallel going through the focus, another ray directed at the center. So this was one of the rules when I taught you the rules. Okay, so this is it. Let me proceed to the sixth rule and the final rule and the most important rule. Okay, so this is the sixth rule. Now here the object is between pole and focus. Okay, so let me draw. See, I have positioned the mirror a little bit forward this time for a reason. Now here is the principal axis, and you can see the principal axis is also going through the mirror. It's also proceeding backwards. Okay, here is the pole. Okay, and here is the this is the focus, this is the center of curvature. Okay, and then if you place the object now over here, supposing I am placing the object here, that is between the pole and the focus, one ray will come parallel to the principal axis. Okay, and it passes through the focus according to the rules of reflection. It passes through the focus. Another ray is given out through this in such a way that is directed at the, it is directed at C. Okay, so I'll draw it straight together only. So this ray was directed at C and it got reflected along the, along C, along the same line. Now if I extend, now remember when you extend this, you should not do it freehand, you must use a scale because these two must be in the same straight line. So if I extend it, okay, and also if I extend this one also, yes, so if I extend this, yes, and see it is about to meet. So it is going to differ from person to person, diagram to diagram where it is going to meet, but you can see they are converging. Okay, so they are definitely going to meet somewhere a little later, somewhere a little early. So this is, see, this is meeting at this point. Now here what mistake happens is people tend to make this like this. This always should fall in the same straight line. Here also this always should fall in the same straight line. Okay, there should be no bend over here, no bend over here. I'll tell you why. Now I'll extend the principal axis a little bit more because my diagram has reached till here. And then here is, I'm going to draw my image, that is, this is the image of, this is the virtual image. So if you place your eyes here, you will get the feeling that the rays are coming from this point. Okay, so here one erect image, these are the characteristics, enlarged image, erect, enlarged behind the mirror, image is formed. Okay, what else? Erect, enlarged behind the mirror, and of course virtual image. Okay, erect and virtual go together. So I get, this is the only case of virtual image in case of, this is the only case of virtual image in case of a concave mirror. Rest all the other images are real images. Now I had told what is a virtual image. Why is it called a virtual image and not a real image? Okay, this is called a virtual image and not a real image because the rays actually don't meet here. Remember, this is an opaque body. The rays are not meeting. Okay, only thing, because of the direction of the rays seem to come from here, seem to be meeting here. That is why we call it a virtual image. Okay, so a virtual image does not need a screen. All this time I was getting image here, here, but wherever I got an image, remember, I will not be able to see the image just like that with the naked eye. I'll have to put a screen at the correct place, then I'll see that the image is formed at that position. Okay, so this is the last diagram. This is the most important diagram for this entire concave mirror, diagrams. Because why? Now why is this diagram so important? Here I want to tell something. This diagram is very, very important because this is the diagram which is used in a shaving mirror, This is used in a shaving mirror. Okay, it is used by doctors to see. They sometimes dentists will put a mirror between the gum and the tooth. Okay, so that is, they'll place the they'll place the mirror between the cheeks and the gum, and they want to see the inside part of the tooth. Okay, the tooth side, the cheek side of the tooth they want to see. Then they will be using this kind of a mirror. So dentists use this mirror. Okay, dentists use, they do use this mirror, and they also use this case. So dentists use this mirror. Okay, they do use this mirror. It will be framed in a small frame which they can put inside your mouth, and this is, they place it between the cheek and the gum, as I said, to see the tooth properly. So these are the two uses of this particular concave mirror. Okay, with that I am going to end the video here today, because the video is becoming a bit too long. So what I'll do is I'll talk about the uses of a concave mirror, different uses of a concave mirror in details in the next video. And I'm also going to talk about the cases of image formed in a convex mirror. We are going to take up convex mirror. We are going to take up its uses in detail in the very next video. That is, this is going to be light part 3. The next one, in light part 4, you can find all those details, uses of concave and convex mirror in a lot of detail. So here in this video, we have finished all the cases of a concave mirror image formation. Okay, so that is it for today. Thanks for watching. If you have liked the video, do not forget to like, share and subscribe. Bye all of you.